So my name is Kathy Demchak. I work at Penn State. I'm talking about high tunnels because I've been working in them for a while, and a number of our growers here have adopted their use. And so I'll share with you some of what we are seeing on the farms. I also want to thank everybody for sticking around here, 8 o'clock, getting probably, 2 hours into this. You might be getting a little, tired of listening, at least maybe to me by the end of this. So anyway, so I want to talk about, high tunnel usage in general. I was asked to talk about some of the niches, and they vary with the grower and the situation. I don't want to delude anybody maybe into thinking that that berries are necessarily going to be the best crop for you. Our growers are doing really well with tomatoes, greens, like you see here, and herbs. And, there's good income per square foot on those crops. And they aren't quite as labor intensive as some of the berries when it comes to harvest. So so I don't want to make people feel like, berries are necessarily the way to go. It really depends on your situation and what you want to be doing. So as far as berries and high tunnels go, though, we do have some growers, as I mentioned, that are growing berries quite successfully. Generally, when they are marketing their berries, it seems, from what I'm hearing, talking to them, that they generally do better profit-wise when they are taking the berries either to farmers markets and sometimes to auctions if they're the only growers or there's a limited berry supply at that time. They can get some really good prices that way. Sometimes, they have a lot of people coming through at the farmers markets. And so the expectations that, maybe you'll get a bargain or something like that, as you might if you come to the farm, the expectations for that's a little lower. And so the prices are, sometimes more likely to be in a range where they can make a profit. So what the growers seem to be headed towards, which sort of matches up with what other folks were saying earlier. One is having early fruit, mainly with the strawberries, is important to them. For some of the growers, having a constant supply with either of the strawberries and the raspberries does seem to help in terms of expectations that customers will come back and expect that, they've had strawberries this week, so they'll have them next week and the week after that, or the same with raspberries. So that can be helpful to them. Also, having late berries helps. And this goes along with one of the earlier slides you saw related to prices in the spring and fall, where, nationally they tend to be higher for those off-season berries. And likewise here, a number of our growers are saying that they're doing quite well with those late berries for both strawberries and raspberries. And then a few of our growers are growing organically grown produce, and they will sell it that way. They're not necessarily certified organic. They will use organic practices and let their customers know that they're using organic practices, but they may not be going through the, through the paperwork and the effort of getting certified organically, just because of, the size of their operations. So what are they growing and how are they growing? So if they're growing strawberries, mainly it tends to be the day neutral berries. And if they're growing raspberries, it tends to be primocane fruiting varieties that they also have a summer crop on. So they have a very long harvest season with those. When they're growing them, they may be growing the strawberries in the ground in something like a plasticulture system, or they may be growing them in containers. It really depends on the grower comfort level with the systems that they're used to using. And, if they're already growing something else in a greenhouse, they tend to feel more comfortable with the containerized production. And then the raspberries are typically being grown in the ground, although containers production does work for raspberries quite well. We've done a fair amount of work with that. Challenge is figuring out how to overwinter the potted raspberries. So we're going to go through some of the challenges that growers have run into with their high tunnel berry production. Looking at some of the different systems, and some of the challenges they've run into are things that are common across crops. So if you're growing in ground strawberries in a tunnel, salt buildup can be an issue. This is mainly an issue in situations where the plastic is on the tunnels year round, so 4-season tunnels. And this happens mainly, becomes a problem mainly when a salt-sensitive crop like strawberries follows a crop that had a high fertilizer requirement. And so there was a salt buildup from the previous crops, and this happens like with tomatoes. And so that's where, where we've seen the situation, and that's what happened with the picture that you're seeing here with these strawberries, where you can see a little bit of salt burn around the edges of the leaves here. Hopefully you can see my cursor and see where I'm pointing that out. And then you actually see the salt on the soil surface to the outside of the row. Now this was after we realized we had a salt problem, and we flushed the salts out into the row middles. And we'll talk about that a little bit more in a minute. But in addition to salts, compaction and soil quality can be an issue with the soil in tunnels. The soil tends not to get a rest, and so it may be used for 10 years in a row. And then, it starts organic matter levels. The friability of the soil gets worse over time. The organic matter levels still may be pretty high, but the soil is just so compacted that it gets to be an issue. And these problems are not necessarily unique just to berries, though. So where do the salts come from? Well, they come from fertilizers. Composts can have a high salt concentration, especially if manure is a component of that compost. And then some of our water sources, like we have here at Rock Springs, and I should point out this research is done in central Pennsylvania at the Horticulture Research Farm at Penn State. There we have a lot of limestone bedrock, and so there are a lot of caves in the area, and so basically there's a lot of calcium and magnesium in the groundwater, and so we get high bicarbonate levels. In some other places in the state, though, sometimes there are issues with sodium chloride in the water from the well sources. So why does this become a problem in high tunnels? Well, you don't have any leaching really, no rain, no snow. You still have the moisture that's in the soil evaporating, and so you tend to get an accumulation of salt at the surface. As I mentioned, sometimes high fertilizer rates are being used, and so you do want to watch the order of the crops. And then you have high temperatures in the tunnel, so you have a lot of evaporation. The soil surface will tend to be dry, so that will wick up moisture out of the soil. And so even though you might have salts accumulating at the soil surface, the problem really, the plants usually aren't affected until after you till the soil and incorporate those salts back down into the root zone and then grow a sensitive crop. So what we recommend folks do is add on a test for salts when you're doing a soil test in a tunnel. If you're using a fertilizer, if you can use one with a low salt index, calcium nitrate is an example of that. That can be helpful. If you're using a compost, recommend you test it before you apply it. And if you have it outside, that you allow some time for it to be outside and to have any salts leach out of it. If you're using a plastic or an organic mulch on the beds, that results in less evaporation. If you can keep the soil moist, that results in less crop stress. And again, planning that order of crops is important. What we did with ours now is we leave the plastic off over the winter. So the plastic typically has a 4-year life. Sometimes we'll get 5 years out of it. But when we're replacing it, we leave it off over the winter. And what you see here in this graph is a whole bunch of tunnels that we had out at our research farm. Each of these numbers is a different tunnel. And what you see is the salt level in that tunnel during the fall, followed by the salt level in the spring after we had left the cover off for just one winter. And so it really did make quite a difference. We're growing some cover crops now, like forage radishes, also to try to break up the soil a bit and reduce some of the compaction. And then the other thing we've been able to do is leach the salts into the row middles when we did, and this is more of a rescue situation, not what you normally want to have to do. But when we had our bad situation with our strawberries, this took about 40 hours of irrigation, 5 days of 8 hours of irrigation a day. And we did manage to move the salts out into the row middles, and the plants did survive and produce very well after that. So another solution, though, to poor soil quality in a tunnel is that some growers are looking at containerized strawberry challenge, containerized strawberry production. They've been doing that for a while, and so a few years back, some of the challenges ran into seemed to be just about everything, in part because growers were using vertical containerized systems that they were purchasing. And they were using perlite as the media. We're having trouble keeping them, moist enough, having issues with the consistency of the moisture levels. With the vertical systems, there was a fair amount of shading in the lower levels of the strawberry crop. And it was kind of a tough system to master. Some folks tried growing strawberries in using different types of media in pots, and sometimes things didn't work out so well there either. And I remember at one point, one summer when we seemed to have a higher number of growers trying some of these systems, that it seemed like it was less than 5% of the production, but probably more than 95% of the time I was on the phone with growers that summer trying to figure out what was going on. So starting in 2015, we had a project looking at different types of plastic covers, as Kim had mentioned. This was out at our high tunnel facility, and we were also looking at these different covers for use on low tunnels. One of the things we figured out, if you remember that graph I had shown you with the different salt levels in different tunnels, was that we wanted to use these tunnels for this experiment. Not only did we find we had different salt levels, we had pH that was different from tunnel to tunnel to tunnel, because at that point, these tunnels had been used for about 15 years for different crops. And so the soil nutrient levels were different in every tunnel, and we realized that we were never going to be able to see what differences there were between the plastics if we were only measuring differences in the soil in these tunnels. So we realized quickly that we needed to grow in containers. And even though we are at a research farm, our irrigation system at our high tunnel facility is challenging, I guess would be the way I would put it, to use. And we also were working, in a situation where we couldn't leave irrigate. We couldn't automate everything as much as we wanted to. We also didn't want to get into a situation where the system we were using would have some difficulties, and we would have some failures in growing in pots. So we wanted to find a friendly system that we could use and the growers could use, and it would be relatively easy to manage. So first thing we did was we realized we needed to be looking at some different media types here. And so we started doing some work, and hopefully you can see the names. I see some things at the top of my screen that might be blocking, but basically we looked at 4 different media. And so what you're seeing is the plants in different, these were grow sleeves, using a 2:1:1 peat perlite, Metromix 360, a 2:1 horticultural peat to coarse perlite mix, and then also core. And so what you see at the top is plants. growing with these 4 different media. And this was a replicated trial. There are a bunch more, sleeves with these treatments. We also had some different fertilizer treatments. And then what you see below is the root systems on these same 4 treatments. So you could plunk these right over top of each other and see how they looked. And so one thing I want to point out is if you look at the plants that were growing in the peat, 2-to-1 peat to perlite mix here, they are a lot greener than the other plants, even though they were all getting the very same fertilizer. And then also you notice that, some of them were a little peaked looking. We did have what turned out to be, we think, some salt issues with core. And so even though we leached that, apparently it needed to be leached more. So what was our conclusion out of all that? Was when we looked at the root systems, what we realized was what was critical, that the roots were healthy. And so when we tried to get the plants out of these growth sleeves, looking down here in the lower right, those plants' root systems were so packed into the roots, into the growth sleeves, that we almost could not get them out of the growth sleeves with this 2-to-1 peat to perlite mix. And so we think that explains that really vigorous root system just increased uptake of nutrients as well, which, is something that seems obvious now when we look back at it, but we think that explained that darker green color to the plants as well. So that was what our root systems were looking like. And we realized that was a bit of a breakthrough. And so that is one of the things that if you want to try growing strawberries in containers, having a good combination of a good water holding capacity and aeration in that container was really important. Now there are other types of media out there that work very well. There is a berry mix out of a company out of Canada that the greenhouse strawberry growers in Ontario are using that seems to provide similar results, maybe even better. I haven't tried it yet, but that took care of a whole lot of our problems. And so, so that was step number 1. Other things that are important to have enough container depth, makes it harder to overwater, and it gives you more water holding capacity. We used 100 parts per million nitrogen constant feed using a 2720 for high bicarbonate water. Our pH tended to be on the low side, somewhere between 5.5 and 6.4, depending on how long we had been watering with our high bicarbonate water. And also planting early was important. And so after using this system for years, with Albion in particular, our yield was generally in the 2 to 2.4 pounds per plant range. Regardless of which tunnel covering we were using, it was somewhere in that range. One thing that wasn't a challenge in the high tunnels was anthracnose. So containerized raspberries, they do well in the soil or in containers. So I'm not sure that you really, would need to grow them in containers unless you wanted to try it. It's relatively easy compared to strawberries. The one problem we did have was with overwintering the containers and moving them around for the winter time. We tried overwintering them in the tunnels, but the temperatures fluctuated a lot. And so they started growing in like February, and that was a problem. What we did find though was we have higher yields in the containers with our raspberries, and fertilizing at the same rate we did with the strawberries at 100 parts per million N. In our year after planting, we were between 4 and 6 pounds of berries per plants, which was pretty astronomical. So another common challenge, of course, in the high tunnels is two-spotted spider mites. Typically, you'll first see some stippling on the lower leaves, and if you don't take care of them, you end up with webbing and spider mites all over the place, like you see in this picture. Not what you want to do. And unfortunately, some of our growers have run into that situation as well. Generally, when they are also trying to control spotted Wingdrosophila. So two-spotted spider mites can be a problem for both crops, regardless of the system. With spotted winged Drosophila and using broad spectrum insecticides can be a bigger problem because the insecticides are often harder on the beneficials than they are on the two-spotted spider mites. Some pesticides do increase how many eggs that two-spotted spider mites lay per female, and so that's a little concerning as well. Pyrethrins are implicated, are one of the classes implicated in that happening. Or types of insecticides implicated. And even if you're using pesticide-free production can be issues. If you think about the environment in the high tunnels tends to be hot and dry. There isn't much moisture on the leaves. And so that's, something spider mites really loves. So we'll use predatory mites. Our growers have gotten some good results with using them as well, as long as they release them when the two-spotted spider mites populations are still low. We've used Neosulus phallacis and Neosulus californicus mix. But I recommend really just asking the supplier that you're getting the mites from. They will want to know things like temperature and humidity in your tunnels, what spider mite populations you are seeing, how big the area is, and they will make a recommendation for what's best to use. If the populations do get away from you a bit, you can knock back the spider mites a bit with just plain water and insecticidal soap and give the predators a leg up. Here's a picture of one eating actually some mite, trying to get to some mite eggs underneath the calyx of the strawberry. So spotted winged Drosophila, we do tend to have actually relatively lower populations of spotted winged Drosophila in tunnels compared to in the field. It's drier, warmer, has lower humidity. Same things that increase the spider mites are not really what spotted winged Drosophila likes. Other things though in the tunnels is you don't have any missed harvests. And one thing we're finding is that if you increase the frequency of harvest of raspberries to either daily or a 2-day harvest interval, you can knock down the spotted winged Drosophila populations quite a bit. Managing the canes so that humidity stays low in the canopy seems to help. Having really thorough harvests helps, and there are some thoughts that maybe using landscape fabric between the rows might help reduce the humidity. And we do recommend refrigerating the fruit right after harvest at as close to 32 degrees as possible until it is sold, especially for the raspberries. Not so much, for the strawberries where we don't see the numbers like we do of spotted winged Drosophila like we do in raspberries. And so some of our growers say they really don't have problems. I'm not sure that that's really the case, but it does seem to help doing these things in tunnels. So some of other growers have moved to using exclusion netting. You do need a way to move air through the tunnel, I think, with fans, and it helps if you have gable end vents. Does plastic type affect spotted winged Drosophila? We were hoping in our study that it might, and it looks like it may when you have a plastic that allows ultraviolet light through. I'd be really curious to, someday see if there's any effect of UVC light maybe on this pest. That'd be pretty cool if there was. You'll notice that spotted winged Drosophila, you see it in these 3 pictures, is always under the undersides of the berries trying to stay out of the light. So another challenge growers often run into is spacing, where they put the plants too close together and run into all sorts of issues related to that. You do want a minimum of 7 feet between the rows. If you cram in an extra row, you tend to reduce your yields per plant with, a higher number of plants, and so you end up with the same yield per tunnel. So we really recommend, keeping them spaced out like you see in this picture, in the front part of the picture, not in the back where there's an extra row in between there. So one other thing I just want to talk about briefly is regardless of what crop you're growing and, where you are, wind and weather can always be a challenge. a while ago, we were gathering some input from growers, and, loss to environmental catastrophe was always one of the top issues they had with tunnels, especially if they had multi-bay tunnels. So this is looking to the west out at our research farm, where we just, have a lot of winds, and weather systems seem to move right down the valley. So the high tunnels would be behind me as I'd be standing looking, at these clouds moving in. And so we did learn some things in our work. And so I just wanted to maybe give you some helpful hints. And most growers seem to feel like these things have worked for them as well. And they have already figured some of them already figured the stuff out before we did. But anyway, so having a site where you can minimize your wind exposure in some way, helps. That doesn't necessarily mean being behind the hill, though, because sometimes you just have winds, come right over the top of that and still take out your tunnels. So if you can establish a windbreak, that's great. We did have one that was white pine and ash trees until emerald ash borer came in, so now it's just white pine. But at any rate, some things that help. One is, if you have a tunnel, is minimizing wind entry into the tunnel. There is some pressure buildup within the tunnels, and pressure changes also. So things that help are having corner baffles in your tunnels, like you see here. If you do have a wind event coming through, rolling the sides down and making sure there's as few gaps as possible helps. So we use these corner baffles. We also have some knee walls to keep some wind from getting underneath the side walls of the tunnels seems to help. And so tunnels where we've had this kind of system, we have not had anywhere near the damage we did in some of our other tunnels. Another thing we've done is we've switched to using Wig Wire Track instead of what might be referred to as cap track, where you have a metal portion that slips in, or that fits into a base. This is the Wig Wire Track's more rigid. You don't need a wood backing to it, and that's where things often start to loosen up as the wood breaks down. It also helps tie the bows together, less expensive too, and it doesn't cut through the plastic like sometimes happens when you are snapping the cap into the base. It can be attached one of two ways depending on whether you have holes in your bows or not. And then anything that avoids movable joints and end walls. This might be a limitation to some of the NRCS regulations. Do want the doors to be multiple pieces, and so I think that might be a concern. I think they don't want it to be one single solid door. But anyway, we did have an end wall tunnel design, and when we got a lot of wind in, when we didn't put the sides down on one occasion, we had our end walls actually flip up over top. And then on the tunnels, not what you want. So you want your end walls to be secured to the frame in multiple locations and also secured at ground level. And a couple other points. One is you want to make sure that your hardware on your tunnel on the protected side away from the wind is as secure as on the windward side. There's actually a lot of turbulence on the downwind side of the tunnel. So we had a big event move through. Tunnels on the windward side were fine. And if you think about it, that plastic had the bows behind it. But on the leeward side, what happened was the plastic was blown outward after our straps popped off. And that's something that, we didn't really realize till we had that happen. Other helpful hints: fixing little holes before they're big ones. Often you'll have tears in the creases in the plastic first. So always have some greenhouse repair tape on hand. We also switched to using bolts with nuts rather than eye screws for attaching our webbing and rope to our baseboards. And then I think this is one of the last points, is minimizing any expanses of plastic you have that don't have any support. If you don't do that, you want to have cross bracing. You want to use triangles where you can, because you can't change the shape of a triangle without changing the length of one of the sides, right? So, so those work out well, putting some cross bracing on. And then if you don't, when you have bigger expanses of plastic on the end walls, the plastic pulls out from behind the batten tape and you get more flexing of that plastic and more pressure on it. So anyway, so conclusions, berries do have potential. You know, we do recommend that you start small with some of these systems, especially if you're mainly used to field production. And, you know, whatever you use just has to work for your situation, for your customers. And then we do recommend, you know, that, you know, once you get used to those systems, you know, you probably want to focus on ones that aren't so fancy that you can't produce high enough yields to justify the cost. So I think we ran maybe a little long there, or at least right up to the end. I don't know if we have time for questions or not. I'd also be happy to stick around after the meeting's over for a few minutes if we want to ask some questions then.
Kathy, there's 2 questions in the chat. One that I'll read, because I think it just went to me, was, do you have any thoughts about targeted cover crops for silt remediation? There's research from this, from high salt fields out west, alfalfa, barley types that they're using.
Yes, so I do not. I have not done any work with that. So yes, if anybody has anything they would like to add into that. Yeah, you know, I mean, I know some of the folks here are starting to do some more work with looking at that, because it turns out we have a really good site for it, you know. But I don't have any thoughts. I know there is interest in that though. And so unfortunately, I can't really add anything to that part of the conversation, but I think it would be just wonderful, you know, if we could figure something out there. And then I see a question from Kim: comparative cost between Metro Mix and the 2-to-1 peat to perlite. Good questions, Kim. So actually the Metro Mix was more expensive, and that was part of the reason we went to the 2-to-1 peat to perlite. What growers have not cared for is having to mix it up themselves. So we did not want to add dolomitic lime because of our high bicarbonate irrigation water. But we found the peat to perlite was quite a lot cheaper, I think less than half as expensive as the Metro Mix. The ratio was measured by volume, and so it was fluffed up peat to perlite. And the peat volume was calculated on a dry basis, and then we added water at the end of it. So good questions, Kim.
Thank you very much, Kathy.
You're welcome. Thank you. And I'm not sharing my screen because I have low bandwidth here. I live in the middle of nowhere. So anyway, thanks everybody for sticking around.